Hi guys, I'm excited to be here today to talk to you about partial indexing and how it can help improve query performance. First off, just a little bit about myself. Thanks for the introduction. My name is Chris Erwin. I'm co-founder of a Toronto-based startup called Elemenio. We're building a future-friendly API-based content management platform. We'll be rolling out to everyone very soon, but check us out at elemenio.io, register for early access, or find me afterwards, and I'd love to tell you more. Okay, so we're all familiar with the importance of indexing our data. However, in my experience, not many people are familiar with the concept of partial indexing, which is an incredibly simple and wonderfully powerful feature of many of today's databases. They provide a really easy way to improve both read and write speeds, as well as reduce the size of our indexes. Okay, so we're sold. Sounds pretty awesome, but really what is a partial index? Well, essentially it's just an index with a where clause. So if you have a table with millions of records, but our queries only look at a small subset of that data, we can use a partial index to index only that same small subset of data. We simply add a where clause to our index, and if some of the predicates from our query match the predicates from our index, we can make use of that partial index. So partial index isn't going to be great for situations where the query is completely dynamic or completely based on user input. However, if part of the query is static and we're only interested in a small subset of data, we can likely use partial indexes to our advantage. So let's take a look at what this looks like in practice. As you can see, it looks exactly like a normal create index statement, except we've added a where clause to the end. This example here actually illustrates a scenario where partial indexes could be useful. Let's say we have a large orders table where we have a variety of different order statuses ranging from new to completed, canceled, shipping, et cetera, et cetera. But we have an application that's only interested in new orders. Well, if we know our application is only going to be interested in a small subset of that data, we can create an index custom tailored to those queries. With that, we'll enjoy faster reads because the index is going to be much smaller and more efficient to scan. We'll have faster writes compared to a full index because we only have to write to the index if the data satisfies our where clause. And we'll have a smaller memory footprint because we're only indexing a small subset of the overall data. Now this part's totally optional, but it's a nice little trick that I've found useful when working with partial indexes. If we create an index and we're only looking at a small subset of data with a where clause, we can create a view with that same where clause, and now we'll be able to query that view and be sure that some of the predicates from our query will match the predicates from our index. So again, totally optional, but it's just a nice little trick for making it easier when using partial indexes. We can actually go get more complex with the queries as well. This is still a pretty relatively simple query, but it goes to show that we can go beyond simply quality matches, and we're going to start looking inside of properties of JSON columns as well. This example highlights another scenario where partial indexes could be useful. We have an events table where we're logging different user events, but we have an employee dashboard where we only want to pull out events from a specific internal IP range. This is a perfect situation for partial indexes because we have a very large table that's going to continue to grow, and we only want to pull out a small subset of that data. And the where clause is going to be static because this IP range is never going to change. So a partial index is going to help us here. So I want to back this up with some numbers for you guys. I'm a baseball fan, so I turned to the mountain of data that baseball provides us. So this is a fairly contrived example, but it does a decent job of highlighting some of the performance gains that we can achieve. I took MLB batting data from the last 140 years, which is about 100,000 rows of data. So it's not a huge data set, but it's big enough for our purposes here. Then I created a query where I wanted to find all the players from the National League with 30 or more home runs and then sort it by year. Again, simple query, but it will do the purposes here. So if we take that query, run it directly against the table without any index, it takes about 16.5 milliseconds, and our index size is 0 because, well, we didn't have an index. If we look at the full index, we've indexed on the 3 columns that we're interested in, and we see we get a dramatic performance improvement. We're now at 1.5 milliseconds for the query, and our index sits at about 2 megs. Now with a partial index, we're actually able to remove some of the columns from the index because they're now part of our where clause. And we can see that we gain some more performance here. We're now below 1 millisecond at 0.7 milliseconds. And more interestingly, the index size is now only 32 kilobytes. So it's much, much smaller than the full index. So if we compare these side by side, we can see that the no index is just generally a bad idea. But partial index compared to a full index, we see a speed increase of 2 times, so it's 2 times faster, but more importantly, it's 70 times smaller. So in this exact example, we could fit 70 partial indexes in the same amount of space that we fit 1 full index. So this becomes really important on hosted platforms where we're kind of memory restricted or where memory is a precious resource. We want our indexes to be as small as possible. So this is a huge win in this case. So everything I've shown so far is based on Postgres, which has supported partial indexing since version 7.2, but it's actually available in several other databases, including SQL Server, SQLite, and MongoDB. Some people will say MySQL supports partial indexing, but most likely what they're referring to is the fact that you can truncate string values in an index, so it's something quite different than what we've talked about here today. So looking at SQL Server, again, it looks very similar to what we're used to. It's a create index statement with a where clause. This might look a little different to some of you if you're not used to SQL Server. It's transact SQL, but everything's very similar here. The only thing that's different with SQL Server is they refer to them as filtered indexes instead of partial indexes. But again, it's just a create index statement with a where clause. And SQL Server has supported this since 2008. Looking at SQLite, this looks exactly like the Postgres example that I showed earlier. The only difference between those two databases would be the functions and operators that you can use between the two databases and the types of indexes that you can create. But otherwise, structurally, it's exactly the same. Create index with a where clause. SQLite supported this since 3.8. And finally, MongoDB. If you're used to Mongo, this is going to look really familiar to you. The only difference here is we have a partial filter expression. In this case, it's just a simple equality match, but you can use any of the Mongo query filters, and you'll be able to create a partial index here as well. And Mongo's supported this since 3.2. So just to wrap up really quickly, partial indexing is super, super easy, really basic stuff, but we can get some really quick performance gains out of it. If you can write a where clause, you can write a partial index. You're going to get faster reads because our indexes are going to be smaller and more efficient to scan. Faster writes compared to a full index because we only write to the index if our where clause is satisfied. We're going to have smaller indexes because we're only indexing a small subset of data, so we're going to have a better chance of fitting that in memory, and it's going to perform better for us. And lastly, it's available on multiple databases. So with that, I encourage you to go take a look at your applications, see if partial indexing could help you out, and hopefully you can get some quick performance gains. So that's it. If you have any questions, you can reach me at Chris Erwin on Twitter. You can reach us, Elemenio, at Elemenio HQ or online at elemento.io. Thank you very much.